So today we're gonna discuss about in 8-bit address. First of all, let us understand the meaning of this instruction, that is to in 8-bit address in our IO, right? So according to the operation in 65H, here 65H is our 8-bit address, not the data. It is very important thing to understand. So let us consider that 19H data is at the address 65H in our IO. So the number of bytes will be 2, one byte for in and other byte for 65H. Operation will be data which is written on 65H will be copied to accumulator. Mode is direct mode because we are directly indicating the data which is 19H to copy on accumulator. Next is effect on flags. There will be no effect as there is no any arithmetic operation is taking place. So next is our instruction cycle. Total number of T states will be 10 T states, 4T for output fetch, 3T for memory read and 3T for IO read. Output fetch to fetch the code of IN in, memory read to read the address, 8-bit address, and IO read to read the data which is written at this IO, right? Therefore, from T1 to T4, output fetch will be conducted. From T5 to T7, memory read will be conducted. And from T8 to T10, IO read will be conducted. During output fetch from T1, arithmetic latch enable will be switched on in T1, switch on state. Again will be switched off. At T5, it will be switched on, and at IO read at T8, it will be switched on. As because we know that arithmetic latch enable itself whenever any new operation get started. Next is A15 to A8, which shows the higher bit of our address. We have considered that 2200H and 2201H for this upcode and our 65H, right? Therefore, the higher bit is 22H. Some unified space will be taken by the microprocessor. Again 22H will be given for this address, and this shows the higher bit of our address which is read by our memory, which is 65H. As there is no any higher bit is there for the address, therefore we have put an 00H, right? Next is multiplexer, which is AD7 to AD0. First of all, it will take 00H for 2200H. Next bit is DBH. DBH is for the data which is put in at this address, which is the upcode of in, right? Next is 22H. For 22H, the lower bit is 01H. Next is 65H, which is written on this address 2201H, 65H, right? Next is the lower byte of this address, which is 65H, and the data which is present on 65H is 19H, which we have considered. Therefore 19H will be there, right? Coming to IO or M bar or S1 and S0, our status lines. So we have read about this, and according to the remembered thing, we have written 011 for output fetch, 010 for memory read, and 110 for IO read, right? Next is memory read and memory write. As memory read is taking place to read the output fetch, therefore memory read will be enabled at this space to read the output fetch of in, which is DBH. Next is to read the 8-bit address, which is 65H. Therefore memory read will be enabled here, and to read the data which is present at 65H address, which is 19H. Therefore memory read will be enabled here, and this memory read bar will be disabled here, right? Next is write bar, memory write bar, which is of no use as there is no any operation in which memory write is taking place.